Alright, so we're going to continue what we were learning yesterday. And what was that we found out yesterday or discovered? What did we discover yesterday in the notes? Anybody? What did we talk about? Good. Okay, we were using the distance formula to find the distance between 2 points, and we found that the distance formula actually comes from what? The Pythagorean theorem. Yeah, thank you. So we found out that the distance formula actually is a manipulation of the Pythagorean theorem. So we're going to build upon that idea today and continue using that and do problems that are similar to yesterday but a little bit different, but using the same idea, using distance formula. So for each of the following problems, a diagram has been provided for you. Label the diagram to find the coordinates of the point described. So in this first one, P is a point on the x-axis, 13 units from the point -3, 5. Find all of the possible coordinates for P. So they're saying that this line given here, this dotted line, we don't know exactly where it's at, but we know that it's going to be 13 units long. And we know that this one's going to be on the x-axis here, so we know the y value is 0, but we don't know exactly where it's going to fall on the x-axis yet. It could be over here, it could be over here, it could actually be where they put it. We don't know where it's at yet. This is the point, a possible P that they're talking about. So this could be one of our P points. Is there any other possible points that could be 13 units away on the x-axis, or is this the only one we're going to get? You think you have an answer, Marie? Alright, so there could be one out here somewhere too. We don't know where yet. It just has to be 13 units away. So that's what we're going for. It has to be on the x-axis. Well, we could have one that's 13 units this way or 13 units this way. Again, we don't know what the x is yet, but we know the y would be 0. Alright, so now we have the triangle, but we are really talking about the distance formula, so let's go ahead, and this box is for your work over here. We're going to go between the 2 points, so we'll start with this point and this one over here, so -3 minus x. We don't have an x value in our second point. Square plus the y value of our original point's 5 minus 0. And we'll square that. And that's going to be equal to what? Who knows what that would be equal to? I plugged this point and this point into my distance formula, and it should be equal to what? 13, exactly. We want the distance to be 13. Alright, so now we just start solving. We need to get the x by itself, sorry. So we need to get rid of the square root, so we're going to square both sides. So that would leave us with -3 minus x squared plus 5 minus 0 squared equals, and 13 squared is 13 times 13. Who can help me out? I see some calculators out there. Got it? 169, yes, thank you. Alright, now we can expand this a little bit. We have -3 minus x, and that quantity is squared, so we can actually multiply out that quantity. So we would get 9 plus 6x plus x squared plus, well, 5 minus 0 is 5. 5 squared is 25. So plus 25 equals 169. Are we okay with how we expanded that? We had the negative 3 minus x, so we did negative 3 minus x times negative 3 minus x. We FOILed that out. That's how we got this answer, and then the 5 minus 0 squared is just 25. And now we have a power of 2 there, so we're actually going to get a quadratic. So we want to get this equal to 0 so we can solve. So if we rearrange, because it's all addition, and combine like terms, we would get x squared plus 6x. And if we add the 9 to the 25, but then subtract the 169 to this side, we would actually get minus 135 equals 0. Now what we need to do is factor. Can be done, may not be an easy one, but go ahead and try to factor this one.
Please excuse the interruption. We need all students taking the Keystone test to report to their classrooms. That's all students taking the Keystone test report to their testing classrooms.
Think you have it, Marie?
Yes, it would be 15 and negative 9.
X plus 15, x minus 9. Very good. So we have our two factors equal to 0. When you multiply those together, you get this quadratic up here. And when we solve, we would get x equals negative 15 or 9. So what does that answer actually tell us? Okay, we found x, but what does that mean?
2 points on the x-axis, so negative 15.
Exactly. So we found both of these points. These points would be negative 15, 0 or 9, 0. Those are the two possible points you could have to be 13 units away from that original point. Exactly. Now, if we weren't able to factor this when we got down to the quadratic, what would you have to do? Quadratic formula. So remember, we have the factoring, but you can also use the quadratic formula. All right, the next problem is similar, but we're talking about this point on the y-axis. So we know the x value has to be 0, but we're looking for a y value now. And we want this to be 2 square roots of 10 units away. Find all the possible coordinates. Well, how many possible coordinates are we going to be able to find again? 2. Yeah, we're going to be able to find 2 again, but we're going to go about it in the same way. Would you guys like to try this one on your own, or would you like me to go through it with you again on this one? Any preference? Alright, let's start the setup. Square root negative 3 minus 0 squared plus 5 minus y squared, because again, we don't know the y value this time. We know we're on the y-axis. Equals 2 square roots of 10. Again, you want to square both sides. So that gets rid of square root. So you have negative 3 squared plus 5 minus y squared equals 4 times 10. Go ahead and try to solve it from there. So you need to get it set equal to 0, combine your like terms, and solve for y. If you've made it there yet, are you able to factor this problem? No, you have to use the quadratic formula. Before you solve the quadratic formula, you should get y squared plus 10y minus 6 equals 0.
Why is it plus 10 minus 1?
Let's see. Let me actually write it out. Let's see. You have 5 minus y. So you get minus 10y. Is that what everybody else got too? Minus 10y. Okay. Minus 10y. Was everybody the same up to this point? Okay. And these are your two answers here, but actually type this into your calculator and get what the decimal versions are. You get y equal to what? Marie, you have them? No? Okay. Anybody have one of the answers?
10.57.
10.57. Anybody have the other? Go ahead.
Negative 0.57.
Yep. 568. Yep. Very good. So if you're listing your points would be 0, 10.57 and 0, negative 0.568. Those are the two possible points that could be on the y-axis. That would be 2 square roots of 10 away from that original point. Any questions about either of those two problems? Question?
Do you know negative y
Well, this point here, we're not saying that this point is right here. We don't know where this point is. We're saying it's at 0, y.
Okay.
So this point could be down here, it could be up here. We're just plotting a point to have a picture. We don't know yet. We just put y there because we actually don't know where that point was. Okay? But we actually solved and we found out, well, one of those points would actually be down here, Marie. And then the other point would be way up here. Okay? So we actually found out what they were, but at the point when we were drawing the picture, we had no idea where that point was going to be. That's just a guideline to go by so you get a mental idea in your head of what they're actually asking. Okay? Any other questions? All right, let's go on to the last problem. So the distance between a line and a point on the line is defined to be the perpendicular distance. Develop and follow a plan to find the distance between the point 9, 5 and the line defined by the equation 4x minus 3y equals negative 4. A picture of the situation has been provided to you. Does anybody have any idea where to start with this one? Or what we might need? They've underlined and bolded this, so this word must be important. Do you know what it means to be perpendicular to something in terms of being on a coordinate plane or a graph?
Wherever it intersects and located.
That is true. That's going to be important, yes. If you get something to intersect it at a right angle on a coordinate plane, what else do we need to know about it? Okay, you might be in the right direction. Okay, you both have the right ideas. You need to put them together. So we're looking for the what? It's dealing with slope and it's dealing with something being opposite. There, that's all the ideas put together. We need the opposite reciprocal of the slope so we can get the opposite reciprocal and then we can find where it's perpendicular to this line. So what we actually need to do is find the slope of this line first. Well, they give us the equation up here, so we need to solve it for y equals mx plus b form to find the slope. So 4x minus 3y equals negative 4. Subtract the 4x. Divide by negative 3. So the slope of this line is what? Our original line is what? The slope of this original line we just found to be what? 4/3. So the slope of our perpendicular line needs to be what? Negative 3/4. So the slope of the perpendicular line, so I'm just going to write perpendicular like that, would be negative 3/4. Okay. So that's going to help us start. Why can't we just start with the distance formula? Why do we have to find this first? What do we need whenever we're plugging into the distance formula? Like if we just look at the original picture, what are we missing? A second point. We're only given one, so we're using this slope now to help us find the second point. So we know the slope of this perpendicular line from this point is this negative 3/4. So we can go up 3, 1, 2, 3, back 4, 1, 2, 3, 4. And it puts us right on that line. So we actually do perpendicular. It is the perpendicular bisector. And now we need to figure out what that point is. So go to the origin and count from the origin to see what the point is. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. So 5, 8. So we have 5, 8, and we have 9, 5. So now we can find the distance from that point to that line. We go back to our distance formula. D equals square root. I'm going to start with this one, so 9 minus 5 squared, plus then I'm going to have 5 minus 8 squared. You guys solve, let me know what you get as a final answer for your distance. Your distance between that point and that line. All right, who has the distance for me? Brianna. Distance is 5. Very good. So the distance is 5 units away. So when you simplify that, you would get the square root of 16 plus 9, so square root of 25, and that simplifies to d equals 5. So your distance should be 5. Any questions on how we went about solving that? Now we were missing a point, so we needed the opposite reciprocal, and that's how we found the line that was perpendicular to that. Alright, so with the remaining time today, I would just like you to work on your homework, so you get a chance to get a jump start on that, and tomorrow we will start the next section.